Alright guys, here's the end of physics where we are trying to measure the coefficient of friction. So we had our little package on the board and we tipped the board up and the package started to slide down at a given point. So let's think about what we're doing there. So we've got a little diagram, force diagram, just like you should always draw. And when we're on an inclined surface, we know friction is pointing against motion. When we tipped it up enough, it started to move. It's experiencing its weight times the sine of theta when it's on the board, because we have to consider the component of its weight that's directed along the board. Its normal force pushes up, and its weight times the cosine of theta is what it's experiencing there. The angle, of course, where we stopped is where it just barely started to move. So right when the object started to slide down the board, we know that W times the sine of theta is equal to friction, right? At that moment, at that height, these two things were equal. And then we got just a little higher, and then it started to slide because this became just a little bigger than friction. So when we measured the height at which it started to slide, which was 0.370 meters, then hopefully right about there was the point where friction and weight times the sine of theta were equal to each other. And then just a little bigger here when it started to slide. So then I solved that here for weight times the sine of theta minus friction is 0. We know that right before it started to slide, it was in equilibrium. We also know the equation for friction is the coefficient of static friction times the normal force. We know our normal force is equal and opposite of weight times the cosine of theta. So we can kind of rearrange here, right? We can put in for friction weight times the sine of theta, right? Weight times the sine of theta was friction right at the point where it was ready to start sliding, just before it did. So that's friction. And we know coefficient of friction times the normal force, which is weight times cosine of theta, is also equal to friction. So we've got these two things equal to friction, and if we solve for the coefficient of friction, which is what we're trying to figure out, then we find it to be the sine of theta divided by the cosine of theta times weight on both. And the weights, of course, cancel out. So we find sine divided by cosine, which we know is tangent by definition. So the coefficient of friction is just the tangent of the angle. So take that in for a minute. The coefficient of friction is just the tangent of the angle at which the thing has friction equal to the downward force, that moment right before it starts to slide. So all we did was measure the height, this height right here, at which the thing started to slide. I also wrote the length of the board, which is the hypotenuse of our triangle. And it's a new board, so you guys don't have the height, but it's 1.225 meters, which I just measured because we didn't do that in class. So the sine of the angle is the opposite of the hypotenuse. That's the height at which the thing started to slide divided by the hypotenuse, which is the length of the board. So we divide that to find, well then if we took inverse sine of that, we'd find theta, which I haven't actually done yet. So let's see if we can aim the calculator here. I don't know if I can calculate in front of you. Oh, the whole world will now know my passcode. Probably everyone does anyway. All right, so we've got 0.37 divided by 1.225 equals that. I want the inverse sine of it. Does my phone do that? Yeah, that didn't work. 0.37 divided by 1.225. Is that second sine? Oh, good. Okay, that's theta. So theta, just not thinking, theta is 17.6 degrees, and I can keep 3 significant figures because that top number has 3. So 17.6 degrees. So, all right. So when we do that, we take the inverse sine of that, we get our theta, which is the angle that the board went to. So to find the coefficient of friction for this given object on this given surface, we would just do coefficient of static friction equals the tangent of that angle, which was 17.6 degrees. So just hit the tangent button. And we find the coefficient of friction, 3 significant figures, to be 0.317. And remember, coefficient of friction has no unit, so that's the coefficient of friction for that little package on our particular board. And remember, friction is different between any 2 different surfaces. So if I used my phone or a notebook or a box or something different, it would have a different coefficient of friction on that board. But this is the particular object that we tested out, which was this on this board. So that's how you do it.